So I think we already took a look at our objectives for today. I do want to just kind of say some introductory things about light. Light is a very complicated thing that we need to know way more physics than we do to really thoroughly understand it. But that's okay, because the complicated parts of it are relatively unimportant for almost any of our observations about what light does or how it behaves or how it travels. I think back about a month ago when we talked about our different forms of energy, I believe we referred to radiant energy, and we said that that's not just like visible light, but it's all of our different kinds of light. Our invisible light also, ultraviolet, gamma rays, X-rays, all that good stuff, right? So there's a whole spectrum of frequencies, and visible light is just a very, very, very narrow range of that spectrum. It's just the frequencies that cause, our retinas to undergo a reaction that then send a signal to our brain, right? And our retinas only can detect a very narrow frequency range. We'll come back to photons in a minute, but sometimes we hear about photons in reference to light. So a healthy way to think about a photon is it's like an individual piece of light, or the smallest amount of light that we could possibly have. We're going to say a tiny bit more about it, though, before we move on. None of that really tells us what light is, though, right? So light is composed of two things. It's composed of an electric field. Right? We haven't talked about electricity yet. That's why light's going to be really difficult for us to get heavily into right now. So light is an electric field that is changing. Right? It's like oscillating. It's changing. And if we have a changing electric field, that creates a magnetic field as well. Okay, so we don't actually have charges moving through space, but we do have an electric field moving through space. And because that electric field is oscillating, that creates a magnetic field. So we have this oscillating electric and magnetic field moving through space. That's light. And that's why we call this stuff electromagnetic radiation. Right? It's electricity and magnetism. Right? But it's just fields moving through space, not pieces of anything moving through space. All right, so when we talk about frequency, when we're talking about the frequency of the light, we're talking about the frequency at which these fields oscillate. When we're talking about the wavelength, right, again, it's related to the distance through space that causes one full oscillation of these things. Right, so it's kind of ultra complicated, but the behavior of light is not ultra complicated at all. Now, one final thing before we start moving into the properties and behavior of this kind of complicated stuff. A photon is way more than just the smallest amount of light. Did we watch any of the, what's it called? Any of like the videos about like the quantum stuff or anything like earlier in the year, like when I was out, or was that just the other section did that one? I think you did too. Yeah, that stuff, right. So probably in those videos, they clued us in to that there's really only like 4 types of interactions between stuff. One of those types of interactions we've studied, quite relatively in depth this year. That's gravity. Another type of interaction we haven't studied too much yet, but we're going to. Right? So that's like electricity and magnetism. And then there were 2 others. What were they? No, all right. So they're both very short-range forces. One is called the strong nuclear force, and then the other is called the weak nuclear force. Right? Those ones we actually don't study this year. I just finished studying this one with my 11th graders. So we just had our test on that like this week. But all of these interactions have a particle that communicates them, right? So when we say that the Earth pulls on us, right, it does that by sending out a particle to tell us, hey, you're being pulled on. And we do the same thing to the Earth. We send out a particle to the Earth saying, hey, we're pulling on you. Anybody know what that particle is called? It's called a graviton. Right? So all of these interactions, all of these forces have a carrier particle. The carrier particle of gravity is the graviton. The carrier particle of the electric and magnetic force is called the photon. Right? So light is how electric and magnetic forces get transmitted, like through space. So the photon, the carrier particle of that, is the same thing as what we're saying the smallest unit of light is. This one I think is called a gluon, and oh boy, what is this one called? I forget what this one's called. So a photon is a little more complicated than just saying that it's the smallest unit of light. And again, it doesn't make any sense, is that what you said?
That was our chem group last year, gluon.
That was your chem group? What does that mean?
Yeah, she named each of the chem groups after different things.
Oh, well, what was the fourth one? Because the fourth one's probably this one. Lepton, no, lepton is not.
Lepton's different.
Yeah, lepton's not carrier particle.
She did different
Hork
ones.
is not carrier particle.
You'd have to ask the older.
Sure. So anyway, we don't need to care about any of that stuff when we're dealing with light this year or next year. Right? So we're just going to really acknowledge that light travels in straight lines, right? Unless we put it into a new medium. But if it's traveling through space, if it's traveling through the atmosphere, it travels in a straight line. And last class, right, we had our sketches that had the hole in the bottom of the can, and then supported light from the filament getting to the lid of the can, and the image of the filament being upside down. Oops, I missed a little bit. Let me just move my hole. And those diagrams actually showed the light traveling as rays, right? So you guys, I think, had geometry last year or the year before, right? What's a ray? That was the question we started class with last time. Ruchi, what's a ray? That's exactly right. So it's a line that starts at a point and then extends in a single direction and like keeps going, right? Well, our light sort of kept going. It got to the lid and then things may have changed a little bit. But if there's nothing in the way, it should keep going. Right. All right? So that's our model for how light travels. All right? So we're going to be dealing with the ray model of light. We can think flashlight beams. We can think laser beams. Right? Those do just go off in a single direction. All right, so a little bit of terminology before we collect some data to bring us back to those homework questions that were maybe a little bit tricky last night. Some objects make their own light. All right? Some objects make their own light. If they do that, they're called a luminous source. All right, so what's one example of a luminous source in this room? Better yet, in your foursomes, can you please each come up with one example of something in this room that creates its own light? All right, I hope you've all come up with at least one example. Amanda, what was yours?
The computer.
My computer? Yeah, so my computer, I guess on the back, has a little apple that's giving off its own light. The screen, which I can see, you can't, is giving off its own light. So sure, I would call that luminous. Megna, what was an example your group said? Yeah, the overhead lights, right? So those things are giving off their own light. We call them luminous sources. A lot of things, though, don't give off their own light, but they send us somebody else's light. If they do that, then we call them an illuminated source. So our attendance sheet hasn't been picked up today yet, right? So it's still hanging up there. I can see it, right? It is sending light to both of my eyes, but it's not luminous. It's just taking some of the light that's hitting it from the overhead lights and redirecting it to me, right? So it is a source of light, but it's illuminated by other things. All right, any follow-up questions about the distinction between a luminous source and an illuminated source? All right, I'm going to ask each foursome to come up with 3 additional things in this room, besides my computer and besides the overhead lights, that are luminous sources. All right, 3 things in this room. All right, go ahead.
Does it count? I mean, I don't know,
kind of stuck on 2, unless I kind of cheat. Oh, no, I got 3. I got 3. And a lot more if we include things that could be luminous but aren't right now. But I think I got my 3. All right, Priyanshi, what's 1? Really? All right. Maybe the display screen on a calculator. It's got me thinking. Tempted to argue against it, but I'll agree. Kylie, what's another?
Projector.
The projector, definitely, right, is a luminous source. It's sending out light. Sure. And then, Jonathan, you got another? Yeah, absolutely. So the motion sensor is actually sending out infrared light. We can see a little red dot on there because there's a tiny amount of red light that it sends out, but it's sending mostly infrared light out. That counts, right? Light isn't just visible. So that's sending infrared out and then looking for reflections off of other things. Did anybody have others? Yeah? Yeah, so we're actually sending out some infrared light as well. That's why we can be seen on like night vision cameras, right? Because we are emitting our own light, so that's interesting. Will?
Camera, like the back of the camera, would be jumping.
Okay, yeah, the back of the camera has a display screen very similar to the laptop, sure. Anything else? Good, so that's a good list. And so it sounds, if we can identify those as luminous ones, then I think we're pretty good. And everything else essentially is illuminated by the overhead lights. Okay, so a couple other pieces of terminology. So when we're thinking about matter that might have light striking it, right, we have a couple different terms to describe what can happen to the light, or at least its ability to let the light through or block it. So opaque, right, that means that no light gets through, right? Like you can't see me, right, like peek of it, right? There's no light that gets through, this is opaque. Your desktops are opaque. What are I got 2 blanks, right? What goes there? Jack, what's 1?
Transparent.
Transparent means that the light goes through really easily and we can see clearly, like through them. So like the windows, right? If I look at the windows, I can very easily see what's on the other side of them, right? Things aren't blurred, they're not obscured. So yeah, those would be transparent. And then what's the third? Magna? Translucent means that, and we had this in the one homework question about the window shades, translucent means light gets through. We can't see very clearly though. Like we can't identify objects clearly through the translucent object, right? So I kind of have like not quite definitions, but at least some thoughts about those things. So opaque does not transmit light. It might reflect light, it might just absorb it, but the light is not getting through those objects. Transparent, the light does get through and it gets through well. Translucent lets light through, but we can't see objects clearly. The light's getting messed with quite a bit as it goes through. I think I gave one example. I sort of gave one example of each. In your foursomes, again, can you come up with 2 examples of each of those that have to be in this room now? Right, 2 examples of opaque, 2 examples of transparent, 2 of translucent. You can't use the windows, you can't use my book, the tabletops, anything else you could use. All right, go ahead.
So we could do, is this a transparent or is this a transparent? I'm not sure if it's transparent. Never translucent. Will is the door and if we look up like Kylie's like plastic covering, this is transparent.
All right, I hear a tiny bit of talking still. So it sounds like we're pretty much done. Let's start easy and begin with opaque. Shri, what was one of your opaque things?
Floor.
The floor. Yeah, the floor. I don't see any light underneath it. Now there probably aren't any sources of light underneath, but I would imagine if we went to the basement and shined a flashlight up, we probably wouldn't see any light. Sure. And then Jenna, what's another opaque thing? You only had one. The wall. Yeah, I think the walls are pretty opaque, right? When the light in our office is on, you don't see light coming through the wall. Sure. All right, transparent. I don't know. Will, what's a transparent thing?
The window.
I said the window. That's you can't use that.
Sorry.
Kat, what's a transparent thing?
The glass.
Those windows. All right. Well, I didn't say those ones. Fine. Maggie.
Like the lenses on glasses.
The lenses on glasses are hopefully transparent. Ben.
The clock covering.
Okay. Do we have anything that's not glass? That is an example of something transparent.
We redeem ourselves.
What? Debatable.
I think it's the curved shape that's.
Oh, I don't know, because when I look at things through it, they kind of look greenish, so I don't know if that perfectly meets our definition of transparent. Ben?
Binder covering.
Might be a little arguable also. I think we're missing an obvious one, starts with A, very short word. Air, right? Air. I can see all you guys pretty clearly, but there's all this air in between us, but it's transparent, so the light goes very cleanly through it. Okay, translucent. Priyanshi, what's something that's translucent? A single sheet of paper. I cannot even see shapes, but I don't see black. I don't see black, right? If I, well, you don't see anything on the screen, but if I turn this around at you, you can definitely see some light getting through, right? So yes, a single sheet of paper would be pretty translucent. Skin, pretty translucent. You can see some of your veins like underneath, right? So that's kind of translucent. If I held, yeah. So yeah, those are some translucent things. All right, good. Good. And here's a few other examples. So opaque, right? This meter stick, we can't see through it at all. This is a microscope slide. We can't even, other than the edges, we can't really see it. So that's good evidence that it's transparent. What's this one? I think it's like wax paper, and what do you think is underneath it?
Meat patty.
I think like hamburger patties, right? So we can see through the wax paper, but not very clearly. It's like very frosted, right? So like wax paper is kind of the classic example of a translucent object. All right. So we're almost ready to collect a little bit of data. I just want to mention the two new variables that you read about in chapter 16.1. We are not going to work very much with these variables. I'm not very interested in doing like examples where we're solving for these things, but I do want us to understand what they are and understand the relationship between them. So the first one is called luminous flux, right? And because the word luminous is there, this is really only referring to luminous objects, or at least it's referring to the light that's leaving objects, right? So luminous flux is a measure of like how much light is leaving an object like in a fixed amount of time, or better yet, the rate at which light is leaving an object, right? So brightness would kind of be very much related to luminous flux, right? A brighter light bulb would have a higher luminous flux than a dimmer light bulb. The SI unit for that is lumens, which is abbreviated LM. I have two like boxes that light bulbs came in. So these are the light bulbs that you can't really buy anymore, at least in a few months you won't be able to. This is from Incandescent Bulb, a 40-watt bulb, and it says right on here, well, 40 watts is telling us how many joules of energy the light bulb is changing from electric into other forms each second, but that's not really telling us the luminous flux, because as we talked about, a lot of that energy is heat, right? That doesn't really count, right? That doesn't really count. But this does tell us what the luminous flux is. What's that say?
505 lumens.
505 lumens, all right? So 505 lumens would be the luminous flux. That's a measure of how much energy, how much light leaves the light bulb that came in here every second. And then this one, it says a party bulb. This says 25 watts, but I think if you have party bulbs, you don't really care so much about the luminous flux. You just want it to kind of look pretty. So this does not have the luminous flux on. If it does, I can't find it. All right. So luminous flux is the rate at which light leaves a source. Illuminance is the rate at which light hits something, right? So there's light hitting my textbook, right? The illuminance is measuring how much light hits it each second, right? What's the rate at which light hits this? And that's going to be different depending on how far away I am from the luminous source, all right? So luminous flux is the rate at which light leaves something. Illuminance or illumination, our book uses synonymously with that, is the rate at which light strikes something. That's measured in a unit called lux, L-U-X. I think that's just Latin for light. And a lux is a lumen per meter squared. And that's what we're going to focus on for the next 10 minutes or so. All right, so I'm not going to ask if there's follow-up questions about those things right now because I want to go ahead and measure some of those values. So let me stop recording, and the battery's going to die anyway.